Again, the Let's Talk Chemistry with Pastor Dan. Let's do a practice set today on the different gas laws, Boyle's law, Charles' law, Gay-Lussac's law. Let's do a quick review. Remember, Boyle's law says we're at constant temperature. Boyle's law doesn't boil. Temperature is not involved. The equation, if we remember from yesterday, P1 V1 is equal to P2 V2. All right, Charles' law. What's constant in Charles' law? Well, if you remember, Charles' law is constant pressure. There's no pressure. It's really easy. Yeah. Equation is V1, dumb chemist joke. V1 over T1 is V2 over T2. If on the Gay-Lussac law, what's left? We did temperature, we did pressure, constant volume. And if it's inversely, it's the same as Charles' law, P1 over T1, P2 over T2. All righty. So let's look at some practice. I have 6 problems here for you to do. There we go. You can either upload those from my site or you can copy those down. Those are the ones we have right there. Let's work through one together. All right, so let's do this one. All right, when the temperature of a gas at constant volume is standard pressure, if the temperature changes to 105 millibars when the temperature is 16.95 degrees Celsius. Now, remember, I said yesterday that preposition, that if, that when, that for, that as, is what we're going to use as a divider. So it's right there. It's if, everything before, and it's constant volume. Constant volume means that it is Gay-Lussac's law, which is P1 over T1 equals P2 over T2. So let's start our values. Standard pressure. Okay, what's standard pressure? Well, we're looking at millibars. So standard pressure in millibars, if you go back to yesterday, that long list there, millibars is 1,013 millibars. Temperature is unknown. What is the temperature? We're looking for that. After the F, pressure is 1,005 millibars, and the temperature is 16.95 degrees Celsius. Now, if you remember yesterday, we said Celsius we aren't crazy about when we work with it because of 0. So we got to convert to Kelvin. We convert to Kelvin by adding 273, 273.00 for this case. So add 273, we get 289.95 Kelvin. Now, I got a little confused when I was doing the lesson yesterday. This is what I was talking about. I'm looking for temperature. Temperature's on the bottom. So therefore, we're going to flip it to make it easier to work with. There we go. So there were T1s on top. You can do the cross multiplication if you want to, and then divide out again. But I just find it's easier just to do the flip and go from there. Well, T1's on top. That's what we want. P1's on the bottom. So we go to the other side. It's going to be on top. So we go from denominator to numerator. Or think about division. It's going to go from dividing to multiplication. So we go on the other side, right? P2 over T2. And then that P1 is going to have to come up. So our equation is going to be T1 is equal to T2 P1 all over P2. Put our values in then. There we go. 289.95 Kelvin times 1,013 millibars all over 1,005 millibars. Now let's look at our association here. I'm going from 1,005 to 1,013. That's going up. According to Gay-Lussac, it's directly proportional. So if 1 goes up, pressure goes up. That means temperature's got to go up. The number should be higher than 289.95. Take your calculator. 289.95 times 1,013. Hit equal. Divide by 1,005 millibars. Hit equal. Our millibars cross out. Be Kelvin. We get 292.3 Kelvin at sig figs. I've got 5, I've got infinite, and I've got 4. Remember, the rule is the least number in the problem for multiplication and division is the most you can have the answer. So 4 would be my answer. We could also convert that to Kelvin Celsius by subtracting 273.0, and we would get 19.3 degrees Celsius. Either of those is correct. All right, let's check our answers then. Here's the answers to the set. There we go. 1, 2, 3, 4, 5, and 6. All right, and there's the answer we got for the last one. All right, awesome. Okay, so that's it for today. Hopefully it wasn't too bad. Take care. God bless.